Well, welcome back. It's 2 o'clock, and I'm going to hand it over to Katie and Will if you want to go ahead and get started on the session. Thank you.
All right, I can crank up on this one. The session's a little bit of two things. One, we were thinking about data and how to get the data that we're collecting into a form people can use rather than just pin level data. What statistical methods people use for it? Here, let's see if I can share this. There. Share. Hopefully, can everybody see that graph? The just handwritten numbers? No? Can't share your screen. Difficulty of the video conference. All right. It's basically what it is just a photocopy out of our field notebook, just a Write in the Rain notebook. And on the left side, it's our 1 through 9 pins. And across the top, it's the 4 quadrants that we measure at each SET station. And most of us collect something similar to that. There are some older SETs that were drilled for 6 positions instead of 4. And most of the ones are now set for 8. So you can do any combination between 1 and 8. But what do we do for the statistical analyses? Once you collect the data, what do we do? We just do a simple linear regression through our data to see our rate of change. Nothing spectacular about it, just what is built into Excel, and we can snap it through the SET, and that's how we get our rate of change on our SET data over time. And that's because our project is based on geology. I said way back before, and Katie said it before, we both are with the South Carolina Geological Survey. And when we got into the SET project, we were interested in seeing if our marshes are drowning in the face of rising sea levels. So we installed our stations to both check for subsidence. Katie can do it. Okay. Yay, Katie. How about click to slide the graphs? Go forward to the graphs, the slide with that. And these. So there's what that is that is not pin level data. That is taking all, in our case, 36 measurements from each station from all 4 quadrants and the 9 pins, averaging to a single number and then tracking it through time. We are doing very simple stuff with this because we were just interested in the net result of the elevation change the SET can pick up and checking for subsidence or uplift using GNSS. In the early days, it was just GPS data, the US array. Now it's GPS plus GLONASS plus Galileo. All the different satellite positioning systems can be used to collect this data. Because we were just interested in the basics. First, is the land moving, subsidence or uplift? And then how are the marshes responding to that? Because other people were collecting the elevation data. And that's how we started in the late 90s. It was just the SET data and just the GNSS data on that. Just the geology. The biology was going to do whatever the biology was going to do. We were just interested in the net results of things. And now, in the case of some of these stations, I know there are other people who have arrays that are even older than this one. But the 2 long graphs on here go all the way back to January 1999. And you can see how the trends go. So where do you pick trends on these graphs? Just for our purposes, when comparing against long-term sea level rise from the local Charleston gauge, we just do the red line on these graphs is just the simple linear regression, snap through the data. But you could easily put second order or even third order sub trends on these graphs if you look at them. So what we wanted to do is, this is what we've done, and I consider this maybe the most basic level of processing of the data from the SETs. What I'd like to hear is, what have other people done with this? What are they using other statistical methods to look at the data? Is there something else we could be doing besides this? I wanted to open it up to the room at this point and see what people are doing, what the data they're actually, what statistics are they throwing at it? Anybody have anything to volunteer or just say that you're doing it the same way?
Hey, Will, this is Jenny Davis with NOAA up here in North Carolina, and we are doing the same thing you're doing. We've played a little bit with looking at pin level trends, kind of the way that Fish and Wildlife does it, but I find that this is the easiest to interpret. And it's pretty straightforward. Everybody seems to grasp it. So we've just not really gone down the road of trying to go any more advanced in this.
Cool. That's reassuring on my end. Anyone else? Lynn says, we only have a few years of data. We're looking at the averages of pin data for each site. Okay, cool. Yeah, I know some people look at micro topography and they produce these type of graphs for individual pins to see what each part of their plots are doing. We just, like I said, we were doing just the basic simple stuff with ours.
Well, I've used generalized additive models before.
Okay, let me write that down.
I will say that those are probably not necessary unless your data shows some nonlinear trends. For most people, the regular old linear regression is going to be just fine.
Oh, that's interesting. I'll have to look in our books. We might have one station that gives us, if you throw a linear regression on it, it comes out flat, but when you look at the data, the scatter's pretty big on it. That might be something to use for that.
It was really helpful for things like sites where we had a hurricane that dumped like a big bunch of sediment, so then you had this big jump in the SET or the elevation level. So like things like that where you would have a reason to suspect, like a biological reason to suspect that it would be nonlinear. That's a good option for GAMs. I've also done in the past stepwise regression, but again, that was more for like a nonlinear kind of scenario, and it gets at a similar thing as what the GAMs do. So those are just other options.
Well, I'm not a statistician, so any of those suggestions I might find useful, maybe someone else finds useful. I was just thinking about the nonlinear jumps. Yeah, we installed these stations in the 90s hoping to start getting tropical storms, and then we didn't have a single tropical storm hit our array until 2015 and 2016. So we were hoping to do that in the early days, but didn't. And just out of curiosity, we saw no signal from Hurricane Sandy in 2012 in any of the stations. That might be a little bit anomalous on the East Coast, but we couldn't see anything. But biological trends, we actually had an alligator wallow in one of our stations many, many years ago. So there's this nice trough through two of the quadrants. And maybe we've always ignored that data when we process it, but it does show up in the graph. And I always put a note alligator on the graph when that happens.
That could be its own paper right there.
If I'd had photographs and actually caught it there, it definitely would have been. All I had were the drag marks and footprints to prove what it was. Chris asks, has anyone looked at TS? Is that the suspended solids, Chris?
Yes.
We have not, I know for us, because we've done the bare basics on this. I do know other people have. Does anybody in this group look at the adjacent waters sediments?
We would probably have at least turbidity for one of our sites where we have a YSI data logger SON deployed. I can't remember what probes are on that. So we might have some of that at one of our sets of sets. But that's as close as we could get.
All right.
This
Yeah, I
is
can see that type of data being statistically analyzed against the SET data to try and make interpretations. Is there a correlation between the local turbidity and changes in the accretion at the plots? So that's getting into the next step of the statistical stuff. Is what else can you add to it to compare against it? Scott Curtis is asking about SET data and water level at the tide station on different time intervals. The swamp data, near swamp data collects an array of water quality parameters. Yeah, I think that station, George Yell's stations, are they part of the swamp network?
They are. Yeah, that's our. I've got a new name for it now, but it is our Sentinel site.
Okay.
What probes are on that water logger, the water quality logger?
Okay, I hadn't keyed into the new name for that, so now I know the new name also.
I can speak a little bit to Scott's question. I think, well, the relationship between set data and water level at a tide station. So we kind of got into that a little bit, and we did not find a statistical correlation between the actual like pin level, the SET data, and what we estimated through using VDatum was the typical amount of water on the marsh platform at a mean high water. So yeah, we looked into that a little bit before our array. We didn't find anything statistically significant, but that's an interesting question, and that's, I think, one of the reasons why we'd like to deploy some water level loggers at our new SECOORA sites.
Yeah, the cost of instrumentation beyond the SET, since you start putting pressure transducers out, or turbidity meters, or going to like an ISCO water collection system for total suspended solids, dramatically increases the cost of the research. So not everybody can do it. And I can't think of very many places that have done it over many, many years, more than 2 or 3 years. So yeah, for those who've asked, those data are good to have, but I just don't know if has anyone here ever heard of anyone installing those permanently adjacent to SETs, or are they all just kind of sort of in the general area maybe of the SETs? All right, that sounds like nobody else has heard about it. I mean, in our dream SET setup, we'd have the instrument, the GNSS, and then these other physical parameters around it. So I think we all dream of adding these things in. The NIRS, I think the Sentinel sites, as George mentioned in their original terminology, to me come the closest to the organizational framework for collecting as many of these parameters as possible. But even that, they're not at every SET. There might be one water collection or one turbidity meter for trying to cover a whole handful of SETs just because of the costs involved. This is all leading towards the metadata discussion. That's the second part of this. So I just wanted to sound everybody out for what they were using to get their numbers. It's brag on the NEARS day. Oh yeah, in a way, their work with the National Geodetic Survey and all that type of stuff, I think everyone they've worked with is doing good.
We love the NEARS.
Say again?
So we love the NEARS.
Yes.
Yeah. I mean, Nikki makes a good
Yeah.
point. I know I've done my letters, so maybe not specifically for the NEAR, but maybe I'll go in and send them new letters for the NEAR.
And this other data that we need to look at to compare statistically to the SET data, water quality, water volume changes, tide elevations, that may be part of the outreach that SECOORA can help with maybe the citizen science groups to connect people to things. Who out there, how many of the citizen science tide loggers are out there now? They're not exactly scientifically dead accurate like the NOAA tide gauges are, but can that type of data be leveraged in your local area? Is it usable enough does it have enough of a confidence interval on it that can be used to compare against our SET data? I guess that's something to think about too. Oh yeah, good. Katie put the metadata. This is from the South Carolina Geological Survey, our publication a couple of years ago on the results of our basic statistics and our rates and the error bars attached to them and stuff. All right, I think this starts moving. Anybody else have anything specifically about data, statistical processing? Anything on that at the moment? All right. As mentioned several times before, the type of data we're collecting is a big deal. That I think has been one of the bigger issues when we all start talking about a standardized SET data sets, is who's collecting what type of data. And in this case, what I mean is what time intervals are they being collected on? I mentioned, it came up in our group discussion just a little while ago. Some people are collecting monthly, some collect quarterly, some collect semi-annually, and some collect annually. That might be a result of the science, how it was set up at the beginning, or it could be financial restraints or logistical restraints on when you can actually access the data. I don't know that we have a solution right now to that answer, but it does need to be addressed because we collect in South Carolina at the survey, collect the data quarterly. It works for us. We get one measurement per growing season of the grasses, saltwater plants out on the marshes. Oh yeah, good. Sporadically, you collect the data as you can. Yeah, just Jenny has that in the comments. That I think is one of the ones we keep coming back to, is how would you integrate the data sets all together when everybody's collecting on a different frequency? I don't have an answer to that. I just have what works for us. But everybody who hasn't thought about this, ponder it. People who might want to get into this information, into this data collection, please ponder that and come back to us with comments or suggestions or thoughts. Stakeholders who are not SET people, how often would you like to see the data? Monthly data collection would, for us, would be 2 permanent employees full-time trying to measure our array every month. That's the type of labor investment it would take to do it. Quarterly, it would probably still would take 2 permanent employees pretty closely assigned to it to do even quarterly and do GNSS on top of it to continue to get really good GNSS data even more often than we do it every 5 years. So it's a lot of manual investment that goes into these. Oh, I was going somewhere with that. Give me a moment. Is there anyone out there who's not an SET worker that has data they would like to be collected on this? Do y'all have any opinions on how often you'd like to see data collected from this?
Hey, Will, this is Josh at FSU. I have a question actually. If I could back up to your data set, and have you been sampling 4 times a year for ever since '99?
Yes, unless weather or there was one year we had a financial commitment that kept us off for 4 measurements, so one entire year. And actually recently we missed a couple of stations because we had a bunch of equipment that was damaged in an electrical accident. But otherwise, if it wasn't weather or wasn't financial equipment related, we go out 4 times a year.
So I have a question then. Could you, if you take your data set and you would just go back and like subsample just to take 2 measurements a year or 1 measurement a year, how much does that change what your long-term linear trend is? Like, can you look at whether or not it's actually worth the effort to do it 4 times a year compared to 1 or 2 times a year?
We've looked at that. I've not done the quantitative analysis on that. That would be like publication grade. Because what, Katie, can you go back to our graphs? All right. If you look at the upper graph on this, you can actually see the year we didn't measure, and that's from on this graph, it's from around 7/15/2003. If y'all can have a screen big enough to read that. That's almost two years the way it's presented here. Yeah, right there. That was when we didn't collect any data because we never went out. What we see in that graph is more motion overall, but if you go to the middle graph for Bennett's Point, post 2005, you kind of see a sine wave in the data.
Mm-hmm.
That sine wave is the seasonal growth and retraction signal in the plants. That's the combination of a below ground biomass injection, rotting, when do the plants store stuff in the roots versus when they take it out versus when it decomposes. I think we see the same linear regression, but the standard error goes wonky unless you measure in the same season every year.
Mm.
So if we measured every spring and every fall, the regression by just not super accurately done. But if we measured spring and fall and only measured spring and fall, it should be about the same linear regression. But if one year we measured spring and fall and the next year we measured summer and winter, then suddenly your error kicks out.
Mm-hmm.
And gets bigger because of that sine wave. It depends on where you hit the waves in that sine wave.
Yeah.
The
I guess
other
I'm just
thing is
wondering.
we get seasonal droughts that may only be 2 months long that we do see in the data. If you look at 2009 in June 2009 in the Bennett's Point graph, or the standard error notation dot on the upper graph for Willamette Island, those 2 drops are lack of rainfall. We actually saw mud cracks at the surface of the marsh desiccated. And if we weren't measuring quarterly, we might have missed that, or it might have been averaged out by the recovery. but that still feeds more into the standard error than into the total regression.
Mm.
Does that make sense at all? I'm not a statistician, so I'm not always good with how I explain this.
No, it does. I just think what's interesting in listening to you is just getting me thinking. I guess it depends what your question is. If we just want to know what the long-term trend is, then it's a totally different approach. Whereas if you want to be able to capture some of the drought impacts, you need to be sampling to be able to account for those. So it comes back to what your question is, I guess.
Yeah, I agree. What's your research goal?
Yeah.
In our case, our research goal was just to see what was going on, and then our climatology people kind of chimed in and said, "Hey, that kind of looks like our Palmer drought index graph in a really ugly fashion." That's one of the things we hope to do is go back through the Palmer drought index for the area and in future work and compare our data versus that data. We just haven't had time. So yeah, but if my advice though is if you're only measuring annually, do everything you can to measure at the same time every year because of that sine curve. It'll make your life easier. If
Yeah,
you're only doing it annually, one time a year, do your best to do it at the same time.
yeah. For effort purposes, we've dropped back. We were doing it quarterly in the ACE near, but we've dropped back to just spring and fall.
And it may come back to logistics. If your sites are only boat accessible, are there weather conditions that might prevent you from getting to a station, that many times a year, or you don't have money to pay for boat time, so you can only, logistics may have a lot to do with how you sample.
Will, this is Jenny again. I
Yeah.
just wanted to say that, yeah, I think this is one of the bigger challenges that Ches was referring to
Yes.
earlier, of
Yeah.
trying to, are we ever really going to be all on the same page because of things like this? And I will say, in our case, we've got a lot of stations that were put in for research projects, right? And so they might have been monitored quarterly for 5 or 6 years, and then when that funding goes away, you get back to them when you can, or we've gone back to ones that Jim Morris put in 20 years ago because we know they're still sitting there and it's still a good resource, but we're not funded to do that. So we do it when we can to extend that record. um, I would love to have the kind of resolution that you have because we can't answer the same kinds of questions. But I don't think, we'll ever get to that point of probably even being annual on all of these things. Just a challenge, when you're thinking about trying to be standardized across the whole group.
Yeah. One of the ways we're able to do this is because we don't collect any other data. We don't spend the next hour trying to collect marker horizon data because the stupid fiddler crabs in the marsh toted off all our feldspar. We don't have the instrumentation to do the turbidity adjacent to these. There are a lot of methods that many SET researchers around the world use that we don't use. So we do have, in that way, we do have the time to do this. So yeah, what are you studying? Is this the only thing you're studying at that plot? Or are you spending 4 hours at each plot collecting other data? This all feeds into the metadata discussion. What goes into your metadata that accompanies your data sets? Let me click through what I have real quick, see if I can do this on my machine to figure out where I need to go next. That's not good. All right. So Katie had the graph up with our station sites, times, averages on it. Katie, can you go back to that? All right. I think that in the metadata, and this is me, and Katie and I have been batting this around, we have minimum requirements at the moment for metadata. And that would be who owns the station, when was it installed, what are our set or original SET, because we still have 2 original SETs in sites in use. I don't know, which version of the SET are you using? Because my rod set is slightly different than the ones I've seen other people buying recently. The new ones are a little bit more refined. I have smaller diameter pins that are more bendy than the new 3/8 inch thick pins that people buy with the new SETs. You know, what needs to be in the metadata? This is not me telling y'all. This is what do people think need to be included in the metadata? Is the station measured quarterly? You know, is time interval, should that be in the metadata? The actual person who collected it, or is it just the agency who collected it? I'm brainstorming this. I've written notes out before on this, and I only come up with about 6 or 8 things for me. What does the group who's doing this, or the group who may want to use this data, what do y'all want? What do y'all need in the metadata? I mean, metadata can be anything. It's free form. You know, we could set up a standard template and everybody enters all of it, or you just enter what you have. Does the plant species that you're in, does that need to be in the metadata for these? What do y'all think? What are the group discussion? What do y'all think? There's no way I covered everything anybody can think of to go in the metadata. I see metadata charts for people who are doing drilling, and the chart's 2 pages long.
I think in general, clearly, the more people collect and more they document, the better that is. Right? There's no two ways around that. So just putting something out there for us to at least begin to follow. It's those 6 things you just said: the date you sampled, the equipment you're using, and when it was constructed, so we know what the difference in the pins are. Those are all things that go into our metadata that the NEAR requires us to do. We know who did the sampling. We know who did the recording, because those are just go down in the notebook. You know, Lawton did the sampling, Denise did the sampling, Grace did the sampling. And so we at least know who's reading the pins, because we know there's some variation on who reads them. So ultimately, the more the better. Just providing a list helps, because that'll remind us to collect it.
Is there anything that someone thinks is they really feel strongly about being in the metadata that I haven't randomly mentioned?
I don't know if I would say I feel strongly about it, but just going back to our discussion in the groups, and it was brought up here, where you have different people measuring the device, and everybody is, there's human error that incurs due to those differences in how you're measuring. I wonder if there's, it's worth to have some type of statistical variation involved due to human error in measurement. I don't know if that needs to be in the metadata, but something to consider.
I agree. We try our best to make sure only one person's reading the rulers for that very reason. And try not to switch rulers. We try and stick with one ruler all the time, so that there's something maybe wonky with that ruler, at least it's a single error that propagates forward. When we change rulers, we stick a note in our data sheets. So that's something that we need to, that's not in the metadata, that we need to consider putting in the metadata too.
The reason why I guess it kind of rings true for us is, our efforts eventually will have undergraduates helping out with this effort to do the measurement, creating a workforce for our purposes. It'll probably be something we definitely need to have in our data with whoever's measuring at that time.
Yeah, that's a good point for the folks that have variable employees or volunteers, whatever, helping. Yeah, that's a good point, Chris. There was some work done oh, I've forgotten the reference now, years ago, that showed a 2 millimeter error between researchers, just setting the instrument up and measuring it, one person versus someone else doing. I don't remember the reference right now. Ches or Jim, y'all might remember that. I think Jim Ladner down in Florida when he was still, was that you, Jim? That was you who did that? Okay. And that was installing an SET in concrete, I believe, and just repeatedly setting the instrument up. Was that it? Yeah, Jim's nodding yes. So they've worked on that under ideal conditions. The support pipe or rod was in concrete, so it didn't move.
Yeah, the Don Cahoon 2000 Cahoon 2000, it's either A or B, one of the 2000 papers where they do the RSET. They actually bolted a receiver to a concrete floor, and they had multiple readers come in and read. So that literature is out there. It's in the data. Yeah, so it's there.
Cool, thanks. I knew y'all been around long enough to remember those, not with my brain failing.
Will,
Yeah.
I know in consolidating all these different data sets, some of you are recording, whether it's polyhaline, oligohaline, mesohaline. Is that something we should be adding consistently, or?
That's a good question. I'm not a biologist, so I don't know what the absolute definition of haline and the salinity environments mean. I can look at plant species but plant species are kind of an average of the salinities there. I don't know if that would be the same thing. Someone who's more on the biology or chemistry into things, can y'all weigh on, should be recording we're recording the plants observed at the stations as you see here in our chart. Are there feelings, comments about the salinities?
I think in general, your vegetative community is going to respond long term to whatever salinity is going on. Some of that long term is going to be over years. Some of it might be if we have a drought and there's less fresh water coming down the Edisto, that's going to begin to change some of our communities, but generally not that fast. So we're going to see changing communities, marsh migration. That's a mouthful. But you can watch the vegetation change, and you can get a feeling for what the salinity is like based on the vegetation around the set station.
Will, if you're talking, we can't hear you. Still can't. But we heard you just fine before. Nope, still can't. Can hear you, Katie.
You can hear me. Okay.
Yeah.
I don't think it'd be anything having to do with sharing screens, but we can. So Yeah, I think the only other thing that we had chatted about was I think, Laura, you made some really, really excellent points in your talk earlier. And I'll just speak to our experience in this paper that you've seen us pull some figures from. I would reiterate the importance of writing as much down as possible. We've had sort of a working kind of a white sheet document going for years. And finally, in 2021, in preparations for writing this paper, we decided to make into like a formal open file report that was available online. And the process of going back in the notes after not having compiled for a while was it was arduous. It was definitely, I think Will would agree with me. It took us quite a while. So I think anyone who's starting this right now, a piece of advice would be to just document as much as possible. Laura, I think you mentioned kind of like a yearly check-in or doing that on some kind of a regular basis, because like you said, I mean, there's staff turnover, there's stuff that happens with your stations. And if you don't like we've lost a few just to migrating tidal creeks. And if you don't document that, and then someone looks at your data set and says, where did station 7 go? And you don't know, then at least you've got something to refer back to. So yeah, sometimes the stuff we write down is incredibly, incredibly specific to these stations and what's going on with the stations. But it's helpful because it also, we can use it to think about questions like what are the effects of drought? What's going on? What other factors could we maybe throw in here and look at that could be affecting our sites? So yeah, I wanted to also chime in on that point because it's a really, really important one.
All right, let's see. Is that working now?
Yes.
Yes, it is.
We can hear you now.
Okay, I hit it with a hammer.
Nice, that always works.
I don't think I have a camera anymore, but at least the mic's working. Yeah, Katie, thank you for bringing that up. Yeah, we tried to capture maybe not exactly site level specifics that we've been talking about here in that OFR white sheets, but yeah, the mention, Laura's mention of their protocol implementation plans stuff really resonated with our OFR. So I guess, yeah, Katie, yeah, we've kind of collected a lot of this over the years, but have never put it in an actual metadata format ourselves. All right, we've got a little bit of time on this. Data, statistics, data collection, metadata. Is there any other questions people have? What I was saying when I was muted was there's a chance that the end users on this, property managers that have upland and marsh systems, intertidal systems, they might want to know what changes in the data rate, elevation rates for the SETs versus changes in salinity. Could that be something they want to know, and that's why it should be in the metadata for them too? Do we have anyone who wants to weigh in on that or thoughts about that? I was thinking about that because at Clemson's property up at Baruch at the North Inlet near, they've documented over 30 years changes from pine forest to intertidal salt marsh.
So I guess on the salinity topic, one thing that comes to mind, so I think we have all of ours in North Carolina kind of, yeah, we say whether it's polyhaline, euryhaline, whatever, but that is, kind of a call based on where it happens to be sitting relative to the ocean, open ocean. Nobody's actually measuring salinity. And so you're making me think it's such an easy thing to at least get a coarse measurement of. Maybe it's worth adding that because it is an interesting story and it can be hard, especially in some of these estuaries, to have a good sense of what that salinity might be just based on the vegetation. Um, I don't know. I think it's something to think about adding in a more rigorous way than what we've done so far.
Cool. Yeah, I know a lot of the sound systems have quite variable salinity across them, and sometimes it's a seasonal change.
I've used pour water salinity in the past. It's nothing to rip a vial of pour water out of a plot while you're there.
Oh, I have never thought about that. I know people who do pore water studies, aqueous geochemists and stuff, but hadn't thought about what pore water salinity versus the SET data would do. Well, at the moment, I'm out of ideas on this. Unless anyone else has some final thoughts, I will let y'all take a break from listening to me talk about things. So thank y'all.
Hey, Will.
Yeah.
Since we do have so many new users on here, I do have some bits of old knowledge that I came up with, or that I've dug out of my hard drive. If anybody wants to see, I have my data sheet. I can show the way I set up my data sheet, just so somebody can get an idea of how this is. So anybody else can share too. Where did I go? I disappeared. I'm not even in the marsh anymore. Weird. Got my camera on. It's just a fort. Anyway, so I've got that, and I also have pulled up our SQL database so people can see how the Park Service does it, if they're interested. If I can share my screens, if anybody's interested. If not, we can end it early or whatever.
I can definitely make you a presenter.
Okay, go for it.
Yeah, I don't think it would hurt to throw those up on the screen.
All right, let's see. Let me see. What am I sharing here? Window. All right. So first off, this is an oldie but goodie, and Jim will appreciate this one. You probably had a hand in making this one, I bet. Did you? You've seen this one, huh, Jim? Jim Morris? Anyway, so this is what Jim Lynch has passed down to me, and this is what I started off using in the 2000s. And this is a template. I've sent it to Dr. Goldberg, so if anybody wants it, reach out to her. So this is just a sample template, and what you do essentially, you have your times up here, and then you have your this is for a 3-pipe station. You have your SET number, position, and pin, and you put these in, and this can run a check on your pin data to make sure that everything's jiving. It also has if-thens to point out higher, if something happened, if it went high or low, that lower than normal. And it calculates intervals for each station. And it also ends up calculating the interval for the site. So you have station. This calculates station slopes, even pin slopes. So this is a one-stop shop for data entry for you people that are getting into it new. This is definitely something worth grabbing. And Jim is Jim Lynch has put some notations in here that you can kind of see how everything works out. And it's pretty handy. So there's that. Anybody have any questions on this particular spreadsheet? No? Okay. Now let me share. Let's see. Let me share another. Let me share what our SET. All right. So this is this is going to be the Park Service. This is a SQL database that was set up pre both Laura and me. So this is the database we put our data in, and what you can, we have it. We have it by network. I only have access to my network, but Laura probably has access to all of the networks. You can go in there and add data. To add data, yeah, that's fine. You go in here and you can add your data. This is at a site I have at Cape Hatteras. You can go in and add your data. We have Mark Horizon data, so everything's in there. You just go down and check and add the data. And then after you add the data, whoops, let me go. You can review and edit our data. So we'll stick in Cape Hatteras since we're right there. We have the ability to check our data, and the way we check our data, we can either do it manually, where you just look at it and read it, but this gives us the option to do a double read. So I can come in here and do a double read, and if it's not right, if it doesn't match, so I'm entering it off my data sheet. If it doesn't match, then I can go back and check the numbers and see why it doesn't match. It's probably just a data entry error. So this essentially prevents data entry. It's a double entry. Ideally, you'd want somebody else to do it. Like I'd enter the data and then I'll hand it off to somebody else that has data access to this database and have them enter the re-enter, double enter the data for me. So that works. And then we can pull reports off of this and get all of our data. So and on this within this database, I also am able to add all of my data sheets. So I add copies of data sheets, and this is, well, of course, this one's upside down. Let me turn that right side up for you. So this is just kind of how I set up my data. It's just an example of a data sheet. Everybody has different data sheets, but it's just an example of data and accretion. So that is that.
Interesting. The double check of the data entries we've done manually with the books in our hands, but never we always have to make sure we read it correctly. But that's an interesting thing to have set up in your system.
Yeah. So you can do that. You can do it that way. That Excel sheet that I had has an ability to double enter, just like you can here. So,
cool.
But like I said, I sent that to Dr. Goldberg, and if you're interested, she can. That's just an example data sheet that I sent out. So you're welcome to to look at it. Hope that helps.
Yeah, cool. Thanks a bunch. I'd not seen y'all's system before, so that's really cool. Any questions for Ches about that? All right, Katie, anything else you can think of we might have missed?
I think that's everything that I had in my notes.
All right, then the last few things, I guess, as far as metadata go, is there's typical metadata items like editing, versioning, items like that always seem that appear in most metadata stuff. I've been focused more on the SET specific things, but I'm sure each institution might have a data management plan that also requires you to add certain things into that. So that type of metadata would be left to the individual research groups. But other than that, like I said before, I'll step away now and turn it back over. And please, if you have suggestions or questions, reach out to us.
Thank you so much, Will and Katie. That was super helpful. And thanks, Chess, for what you shared. And we'll make those spreadsheets available to you once we have a moment. I would like to give a shout out August 5th, and I'll put it in the chat. We're planning a webinar, and we don't have the title yet, or the speaker is organizing the title and abstract, but it'll be focused on this new datum, the GravD. I'm going to post a link. I guess it's one that has been requested by community of practice members to learn more about. So August 5th in the afternoon, and I'll send more information once we've squared it away. But if you could just, if you're interested, to put aside that time in the afternoon, August 5th, if you're interested in this different vertical datum than the NAV 88. So we're working on that. I don't know, Debra, are you available since we're almost done. If you have time to do some closing remarks, we'd really appreciate it.
Sure. Thanks, Nissa. And really great day. I was able to participate for most of it and learned a lot. I think what struck me most is the collaborative nature of all of you and the willingness to share what you've learned, good and bad, about the challenges of using and collecting set data. And I also want to take a moment to thank Nissa and Riley and Bailey and Claire and everyone else that helped plan the meeting. And of course, all of you, because participating virtually is a challenge for a whole day. Hopefully we can set something up at a future date in person. One of the things I was looking for today was evidence that the community values what we're spending our money on. And so I sense that's the case. I know there's a range of experience in this group right now, but as you interact with Nissa and her team, just making sure she understands what's a priority for you if we're going to continue making investments in this set network would be super valuable. So I don't know if there's another slide. We will be, and when I'm using the euphemistic, Claire will be uploading a lot of the materials, all of the materials from the meeting, along with Nissa and the team. So that'll be available. And then there are lots of ways to stay in touch with SECOORA and what we're doing. As I mentioned earlier, we're feeling a bit more optimistic about our funding, but you all read the papers. Who knows what's going to happen? But for now, we'll continue this work, and it looks like we'll have at least a couple more years of opportunity to make some investments. So that's all I have, Nissa. If I didn't cover something, I'll just hand it.
That's perfect. Thank you. And thank you for being our fearless leader. It's been very trying times. And for you to get the acknowledgement from Congress that SECOORA is critical and this work is also critical. Can't thank you enough. It's not easy. So much appreciated. Well, unless there are any final thoughts, we will leave it there. The session is recorded, so we will share that. And if you would reach out, if you would like to join our community of practice separate from attending this workshop, you don't necessarily need to have joined the community of practice, but if you would like to, please email me and we'll make sure to add you to our listserv. And thank you again for attending. Thank you to the moderators, and we appreciate your support. Thank you. And that's it. You are free to